Hi everybody. Hope you had a great lunch, and thanks so much for this opportunity to talk about our work. So this is collaboration between our lab, Turku NLP in Finland, the National Library of Finland, Hugging Face, and AMD. And this work was most of what I'm going to be talking about was recently presented at the MNLP, so my apologies in advance to anyone who may have seen that one. This will be slightly repetitive. So I'm sure it needs no saying to this audience that large language models have been enormously influential in NLP recently. And as I'm sure you also know, the primary focus of language model development tends to be on large languages such as English. Looking from the perspective of Finnish, most of the models available today, especially regrettably open models, have very limited capacity for the Finnish language. And in this work, we introduce the first large or very large generative language models for Finnish, ranging from a bit under 200 million parameters to somewhat under 200 billion. So Finnish is a language spoken in total by under 6 million people worldwide. And while it is a Nordic language, it's not a North Germanic language. It has no close neighbors in the same language family. More or less anywhere. In particular, it has no large neighbors in the same language family that we could draw on for support. So a key challenge for our work here is where can we find enough data to train large models for Finnish? So at the beginning of this effort, we made a fairly long and concentrated effort to put together all of the data sources we could find for Finnish. We combined 3 web crawls, including a targeted crawl for Finnish websites previously created in our lab. We drew on various national library resources, social media, open resources such as the Finnish Wikipedia, and finally Finnish news resources, which were made available by the Finnish Language Bank. We put together in total approximately 38 billion tokens of text after deduplication and cleaning. And we did a bit of weighing to emphasize data sets that we considered of particularly high quality, but at this stage, not radically changing the distribution. And the corpus we put together here is exclusively Finnish. So this is a monolingual, not a multilingual focus. We did a bunch of fairly standard processing in order to mitigate some of the risks associated with large language model training on the data level. So we did deduplication, first exact document level deduplication using just simple hashing, and then paragraph level deduplication using n-gram overlap. To remove the most toxic material from our training data set, we used a custom classifier, BERT-based classifier using a model we had previously created for Finnish that was trained on a machine translated version of the jigsaw toxicity corpus. Finally, in order to avoid, or shall we say, minimize the risk that the models will create or generate personal data, we applied a custom rule and regular expression-based system that removes things that could be phone numbers, social security numbers, email addresses, and so on. And so coming back to the core question of how large a model can we train on the resources that can be put together for a language of this size? looking at this from the perspective of training chinchilla optimal models, we find that the dataset size we have here at 38 billion tokens would support somewhere in the low billions of parameters for training a chinchilla optimal model on one epoch on this data. By contrast, we had relatively generous computational resources available to us that could potentially allow us to train models up to tens of billions of parameters. So what we explored as a potential solution to bridging at least part of this gap was repeating training data. So this is an experiment, a preliminary experiment we did on English using GPT-3, on MC4 Finnish using GPT-3 XL model. So we explored what happens when we do multiple epochs over this data. And our estimates from these somewhat limited experiments were that we could do 4 epochs over the data without negatively impacting the final validation of the final validation loss of the model, and up to 14 without the validation loss starting to trend upwards, which would obviously be a signal of overfitting. We did see clear overfitting at 40 epochs over the training data, and of course, increasingly more severe overfitting for additional epochs past that. So based on this preliminary experiment, we estimated that we might be able to do approximately 10 repetitions or 10 epochs over our limited data without harming model quality. I should also note that at the same time as we were doing this, we were also collaborating with Hugging Face on a more comprehensive evaluation of the same question. And the findings were broadly in line with our preliminary experiments, finding that up to 4 epochs over the data, the repeated data is almost as good for final loss as new data, and 40 times repetition is not a great idea. Note from this work was that we did not know of by the time we started training our models was that augmenting natural language training data with code can help. So doing 4 epochs over the original data with an additional 50% added code into the final training data set could allow up to 8 times the amount of data for training that you have in your original, like, small natural language data set. But this is information. This work was finished only after we completed our training. So we chose to create models matching the GPT-3 family. And based on our estimates of what we can do in a monolingual setting, we chose to make the GPT-3 style models up to 13 billion parameters trained from scratch on just the Finnish data we had put together, to create a 176 billion parameter, the largest GPT-3 model that was capable of generating Finnish. We continued to pre-train the Bloom model. And we had the Bloom architecture, which is a fairly conventional GPT-3 model with some differences in normalization as well as alibi positional encodings. We created, for the models trained from scratch, a custom tokenizer with a fairly large vocabulary, as Finnish is a morphologically rich agglutinative language. And further following the GPT-3 pre-training protocol, we trained for 300 billion tokens for the models trained from scratch. So that's 8 epochs over the data we had managed to put together. For the Bloom, we trained for an additional 40 billion tokens, starting from a model that had already seen 365 billion. For the software, we used an AMD port that we created for Megatron Deep Speed, specifically the big science branch that was used to train Bloom. And our parameter settings simply follow those of GPT-3. The models were trained in late 2022 on the Lumi supercomputer. We had a pilot project on this system. Lumi is the fastest supercomputer in Europe, and last I checked, still the fifth fastest in the world. It's a rather impressive machine, especially considering its location in a small country like Finland. There are almost 3,000 GPU nodes, each with 4 MI250X devices. So that's about 24,000 graphics computing dice, which roughly corresponds to a GPU. In our experiments working on the pilot, we scaled up to about 1,500 GPUs at top. We had a bit of a struggle with the AMD platform to begin with. So the port of various Megatron Deep Speed kernels, originally written in CUDA, was somewhat imperfect, and we lost some of our time and suffered some gray hair, I suspect, to fixing some bugs in these ROCm kernels. And we had a bunch of other problems initially. I shouldn't pretend this was a straightforward process, but I am happy to say that after we got the basic framework more or less nailed down, we had a remarkably stable training process, and our validation loss curves look the way you would hope. There's very few spikes or instabilities, almost exclusively monotonically decreasing, and they sort the models by size the way you would hope. To make a more serious evaluation of the capabilities of our models, we required some evaluation data for Finnish. And because none existed for this specific purpose at the beginning of our work, we drew on the big benchmark data sets. We took a selection of these that we believed would support the evaluation of Finnish models, so that weren't enormously culturally bound or too difficult or anything like that. We machine translated them using DeepL, and then all examples were manually examined by native annotators who corrected any machine translation errors, as well as removed any questions that were judged to be too culturally dependent on the source language. And this is a summary of our evaluation results on, these are specifically 3-shot results. And just to take note of some points on this graph. So we first see here, so on the left, we have smaller models, on the right, larger, and the y-axis is simply aggregate performance on this evaluation data set. So on the bottom left, we see previously proposed models for Finnish. We fairly clearly outperformed those also for equal sizes. And we do find the trend we hope to see, of course, in these evaluations. That is, as we make a bigger model, we get better performance in almost all cases. We do see a dip at 13 billion. So the 13 billion parameter model is performing slightly worse than the 8 or 7 billion parameter model. And we suspect that we are actually suffering some overfitting at this point. So the 8 times repetition for a model with this capacity is a bit too much. Also, the 176 billion parameter Bloom model adapted to Finnish does outperform all of the monolingual models by quite a substantial margin. We also evaluated its performance in English tasks and found no statistically significant degradation. I perhaps forgot to mention we did mix in the original Bloom training data with our Finnish data for continuing to pre-train this model in order specifically to preserve its English capabilities as well as those it has in other languages. In current and future work, so what I talked about here was the FinGPT model, which covers only one language, Finnish, up to 13 billion parameters, monolingual models trained on 300 billion tokens with a Bloom architecture and general training process. We're currently collaborating with Silo AI, a company in Finland, to create models called Poro. Some of these checkpoints are already released. I believe we released a 70% train checkpoint just today. This model covers Finnish, English, as well as code. So we've learned some of our lessons there. We're now taking a multilingual approach to extending the capabilities and, of course, the data. And we're also including programming languages. Poro is a 33 billion parameter model that we're training for 1 trillion tokens. And this uses the same framework and the same model architectures as the FinGPT models. We're also preparing or have just started training 2 additional models that we're planning. These are internal preliminary names, but there is a family of models we're currently calling Viking. These are all of the Nordic languages, including Finnish, as well as English and programming languages. We're training 3 models ranging 7 to 33 billion parameters on 2 trillion tokens. And here we've upgraded to a more recent framework and llama-like architecture. The longer-term ambition is to create models that cover all European languages, specifically at a minimum, all official EU languages. So this would be at least 24 languages. We will be also including programming languages. And here we are aiming for over 100 billion parameters at the top end. So, and we will be training for 4 trillion tokens there. So in brief conclusion, we here introduced 8 new models for Finnish, the FinGPT family of monolingual models trained from scratch, and an adaptation of Bloom. We introduced a new evaluation dataset for Finnish. We established substantial improvements over previously released open Finnish models. I didn't go into the issues we have with these models, but we did evaluate and find the typical problems you would expect for a model that hasn't been fine-tuned in any way, or rather aligned in any way. So the model does generate, on occasion, toxic outputs. It suffers from the biases you would expect to find in internet-based training data and the usual hallucinations. The models are available at this URL and through Hugging Face. We're releasing or have released these models under the Apache 2 license, so they are genuinely open. And as I mentioned, we're currently working towards models for all EU languages, and we're also exploring instruction fine-tuned as well as dialogue models. In this process, we're trying to be maximally open. We're releasing all of the data we can, as well as all of the models under very generous, liberal licenses. And we are very, very open to all forms of collaboration. So please do feel free to get in touch if you're interested in any part of this work or in collaboration along these lines. All right. And with that, I will leave open my slide for on acknowledgements because I believe I am just out of time, and I will stop there. Thanks.